This is a video for the third page of Notes 3.4, and we are going to try to make a discovery about irrational and imaginary zeros of polynomial functions. So to begin, we're going to solve a quadratic equation, and then we are going to find the zeros of a quadratic function. And then we're going to look at those solutions that we get and draw some conjectures about it. So I'm going to solve one of them by completing the square and the other by quadratic formula, just so we can practice both methods. So let's complete the square for the first example. So for number one, when completing the square in this context, the first thing I want to do is move the 3 to the other side. And then I'm going to add a number to the left side of the equation and the right. And the number that I need to add is what will make x squared minus 2x into a perfect square trinomial. That number is going to be b over 2 squared. B is negative 2. That's this coefficient of x over 2 squared, which is negative 1 squared, which is 1. So we're going to add 1 to the left side of the equation, and likewise, we're going to add 1 to the right side to make sure we have an equivalent equation. The left side is now a perfect square trinomial that factors as x minus 1 quantity squared. The right side is negative 2. The next thing we're going to do is take the square root of both sides. That's called extracting square roots. That leaves us with x minus 1 equals plus or minus the square root of negative 2. So then we got x equals 1 plus or minus, adding 1 to both sides. The square root of negative 2 is I rad 2. So those are our solutions for that equation. The next one, I want to find the zeros of x squared minus 2x minus 2. This doesn't factor. So let's review quadratic formula. So quadratic formula is going to be negative b, so 2 plus or minus the square root of b squared, which will be negative 2 squared, minus 4 times a times c, so minus 4 times a, which is 1, times c, which is negative 2, all over 2a, which is 2. So we have 2 plus or minus the square root of 4 plus 8, which is 12, over 2. So that's 2 plus or minus the square root of 12. 12 is 4 times 3, so this is 2 rad 3 over 2. And now we can divide both terms in the numerators, or actually all the terms by 2, which will leave us with 1 plus or minus rad 3. So these are the zeros. 1 plus or minus rad 3. All right, so in looking at these answers, we're going to draw some conclusions, right? So before that, we want to remember what is the conjugate of 1 plus rad 5. We used this when we were simplifying, rationalizing the denominator, essentially. So the conjugate means change the sign of the second term. So that's going to be 1 minus rad 5. This is also called the complex conjugate when it's in terms of complex numbers with imaginary numbers. So this will be 1 plus 3i. So number 5 says, think about the quadratic formula. So we can look at the answers that we got from the quadratic formula and the solutions that we found in numbers 1 and 2 above. And can we draw any conclusion about irrational and imaginary zeros? So the quadratic formula, I'm going to write that down. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what conclusion can we draw? If we look at these, it seems like irrational, like the solution to number 1, and imaginary zeros come in pairs. So that is actually true. So if we're given one imaginary zero, for example, if we're told that 1 minus 3i is a 0, we know that we will also have the complex conjugate 1 plus 3i will also be a 0. And if we're given an irrational 0, like 1 plus rad 5, or a solution, that's the same meaning, then another solution would be 1 minus rad 5. And if we think about the quadratic formula and how we get irrational and imaginary zeros, we can understand why irrational and imaginary zeros are polynomial functions with real coefficients always come in conjugate pairs, right? Because if we look at the quadratic formula, we'll see that we'll have plus or minus the square root of b squared minus 4ac. And if b squared minus 4ac is not a perfect square, we will be left with an irrational number or an imaginary number if that value turns out to be negative. So this leads us to the conjugates theorem, and that is that complex zeros and irrational zeros of the form a plus or minus rad b always come in conjugate pairs. And given a polynomial f of x with real coefficients, remember you have to have real coefficients, irrational zeros of the form a plus or minus rad b and complex zeros always come in conjugate pairs. So if a plus rad b is a 0, then a minus rad b is also a 0. A must be rational and rad b must be irrational, otherwise this wouldn't be true. And if a plus bi is an imaginary 0, then the complex conjugate a minus bi is also a 0.